Okay, so here I want to show you again how you can do the genome assembly using that program ABySS. So working through your command line. So remember the first thing that we did, and so if you weren't able to do this in class, you can do it now. So Mamba create name, and we created an environment in Mamba called genome assembly. I already did this in class, so it may or may not work. It might tell me I already have it, so let's see. Okay, so then I can always activate it by typing Mamba activate genome assembly. Some of you, I had mentioned in class, may have had to use Conda instead of Mamba. So wherever I type Mamba, you would just replace it with Conda. So once we have the genome assembly environment, we activate it. So anytime we're doing genome assembly stuff, we want it to say genome assembly up here at the front. So next we want to install the ABySS program. So Mamba install, and then we have to tell it which channels to look for. Look for either bioconda or conda forge, and then we'll type ABySS. Okay. And it might say that I already have it or not, that's fine too. Okay, so you can see how quickly that got done. Now I want to set it up to run. So I actually put in a different external hard drive. This is my CSU stand backup. In here, I'm gonna create a new folder called Bioinformatics. Within Bioinformatics, I'm gonna create a new folder called Assembly. And in here, I want to put my sequencing reads, and I have those somewhere else, so I'll just put them over here. So remember, these were available for you to download on Canvas, but it had a different ending. It ended in 001. So we can just rename them to be very simple. So the one that has R1, we're just going to rename it to Reads 1. And reads 2. So just like that. Now we want to make sure that we are working in our working directory. So on a Mac, it's a little bit easier. You should, and of course I had trouble in class today, but you should be able to do CD and then drag the folder, because I'm not sitting right in front of you, that's why it worked. And then hit enter and double check. Let's make sure, okay, my sequencing reads are there. That's great. Now I'm ready to do ABySS. Now those of you who are on a Windows computer, for some of you it was working that we were able to do the shift right click on your file or on your folder on your external hard drive and open the Linux shell there. For other people, it didn't work quite as well, but what did work, or what can work, is if you type, let me make this bigger so you can, or I don't know, maybe I have to type something first. At your prompt in your shell, you can type mnt/d. Actually, you would do cd, right? mnt/d. And if you hit enter, in theory, it should take you there to your D drive, or if it's called your F drive, whatever drive it's called. And for most people, it's called D. Then you can ls and see what folders are in there. I don't know why it always wants to default to capital. And then you can navigate into your, let's say you do have your folder right there called bioinformatics/assembly, right? It should work something like that. If this did not work for you, I figured out a solution with Taylor, and I will post a video for that in just a little bit of what we did for that. Okay, so either way, once you're in your assembly folder, your reads are in there, we can run ABySS. So we do ABySS-PE. So this is saying that we're going to do ABySS paired end, because we have paired end reads. We set our k-mers for 96, so k equals 96. We tell it that we want it to use like 2 gigs of memory, basically. For a bacterial genome, this is pretty good. We don't really need it to be any higher. If we were doing eukaryotic genomes, we might revisit that. We'll say in equals, and then we use an apostrophe, not a quotation. And then we just want to make sure that we have our files typed correctly. Reads.fastq.gz and reads2.fastq.gz. Your files may be unzipped. They may not have the .gz, and that's okay. Or they may have the gz, and that's okay too. So then we'll go ahead and hit enter. Ooh, I must have typed something wrong. Let's see. I did something wrong. I didn't give it a name. See? And then I just figure out what I did wrong. Okay, try it again. ABySS PE K equals 96. Let me do this first. Name equals salmonella. I should have looked it up before I tried to do it from memory, but that's okay. Just takes a minute to figure out what I did wrong. 2G in equals Now we'll try it again. ABySS PE, name is salmonella, K is 96, B is 2G, in is reads 1 and reads 2. Okay, so now it's working. Okay, so it's doing whatever it is it wants to do the assembly. And we'll know it's working if we look here, we can see that it started to generate a file. So I'm going to go ahead and pause this and wait until it's finished, and then we'll see what the results look like. And I just thought of something, you know, one thing that you can do while you are waiting for this to run is you can actually get things kind of set up so that you could get it ready to upload to GitHub, right? So that we can showcase what you've done on GitHub. So I'm creating a new text file, and I'm literally going to paste my code in here. And you might notice that sometimes when I give you files, I put like a hashtag and then I start typing stuff. Those are notes that can help explain what you're doing. And so here you're doing ABySS on paired and reads, k-mer 96 base pair. Oh, let's see, not k-mer, k-mer. And this code actually needs to have name salmonella. Okay. On putative salmonella genome. So it has your code in here, and it has some notes about why you're doing the code. And then you can save this file as just a regular text file within the folder where you're working. So bioinformatics, assembly, and I'm just going to call this assembly code, and it'll save it as a .text file, and that's totally fine. And so what this will allow you to do is when you're doing your upload to GitHub, you'll have your code that you remember what you did, so you don't have to go back and look it up. Okay, so that's a nice thing that I like to do so that I have it there with me. So I hit save, and now you see in here I now have my assembly code as well, so I know what code I did. So I'm going to pause the video again and let it keep running. Okay, so I got my prompt back, so I know that my sequencing is done. And so it gave me all of these files, and that's great. Here it printed out the list of the unitig number, contig number, scaffold number. So like I mentioned in class, unitig is more than contig, is more than scaffold, so scaffold should be the fewest. It gives you the N50 number, which is really important. It gives you like the max size of a scaffold. It gives you that L50, so it takes 6 scaffolds to have 50% of the genome. It gives you the complete genome size, and it tells you like that's the file you could look at. You could also find that same information, like let's say you didn't copy it down, you can find it here in this .csv file as well. So it summarizes it for you if you don't copy it down. For me, this is a little bit cluttered. So what I'm going to do is I'm going to, within assembly, I'm going to create a new folder. I'm going to call it ABySS output. Oops, do that. Oh, it created it above, so I'm just going to move it into assembly, and I'm going to select all of these files and just move them into ABySS output. Perfect. And then just again, to keep everything organized, I'm going to do sequences. I'm going to put these in here. So once you've like got everything kind of done, you can go ahead and just move stuff around. And so now my my area is a little bit tidier. I kind of know where I'm working now. And so that's how either on, the Windows or on the Mac, you should get your results from ABySS. Okay. So I'll create more videos to help you along with the rest of the stuff that we're doing.